Welcome to One Time Academy physics lessons. Today we shall be looking at a resultant force. We want to talk about force and motion. So let us begin. So a resultant force, when several forces act on a body, the resultant force or the overall force on the body can be found by adding. So we can add by adding together forces which act in the same direction, or by subtracting the forces which act in opposite directions. So let's look at this one. The first example, we have two forces here. They are acting on opposite directions. So we have 5 newtons acting on this object, 5 newtons which is acting to the left, and another force 5 newtons acting to the right. So if we want to find the resultant force for this object, what we will do, we are going, because these are opposite forces, it means we are going to subtract them. So we will say 5 newtons minus 5 newtons, and we are going to get 0. So in other words, the resultant force here is 0 newtons, or there is no resultant force. The force, we say the force are balanced. We say the force here have balanced. Also, when we have two forces that are acting on the same direction, so we are going to add. So we have a force which is 3 newtons and another one which is 7 newtons, and they are all acting to the right or to the east. So we are going to say the resultant force is 3 newtons plus 7 newtons, and we get 10 newtons to the right. So remember, a force is a vector quantity and it will have a direction. And then here we have two forces acting now on opposite directions, 7 newtons and 3 newtons. So to get the resultant force, we subtract this one. So it's 7 newtons minus 3 newtons, which is going to be 4 newtons. So there was a mistake here. It's supposed to be 3 newtons. And then the resultant force is going to be in the direction of the bigger force, which is this direction, to the left. So it's going to be 4 newtons to the left. So that is the resultant force of this object. All right, so now we have looked at the resultant force. I want us to proceed to our next slide here. Balanced forces create a state of equilibrium. Balanced forces, we say, create a state of equilibrium. If the forces have balanced, we will come with a state of equilibrium. So for example, we looked at this one in the previous slide, where we have 5 newtons to the left and 5 newtons to the right. So the resultant force here, we said it's 0 newtons. And now these forces have balanced. So this occurs when there are two opposite but equal forces acting on the same object. If you have two forces that are equal but opposite, so we are going to get balanced forces, or the resultant force is going to be 0. So this object now is said to be at equilibrium. In other words, it's going to be stable. It is going to be equilibrium. So we shall see what happens if this object was moving and what happens if this object is at rest. So we shall see what happens if we have the resultant force of 0 newtons. And then now we have when the forces that act on an object are balanced, when the forces that act on an object are balanced, there is no resultant force. So we have said that the body will either remain at rest or will continue sorry for the interruption. So I was saying, when forces act on an object if balanced, we say there is going to be no resultant force. In other words, the body will either remain at rest or continue to move in a straight line at a constant speed. So let's look at these examples. So we're saying if the body is at rest, it will remain at rest. Or if it was moving, it is going to continue at that speed in the same direction. So let's look at this first example. So here we have a spring here. There are two forces acting on this spring. So there is the tension force on the spring, and then there is a weight. So this is the object. So there are forces acting on this object is the tension by the spring and the weight. So if these two forces, the tension and the weight, balance or are equal, so this spring will remain at the same position. It will remain at rest. It is not going to move down or move up, but it will just stand still or remain here at the same position. So that is what we mean when we say the force, the object, the body will either remain at rest or continue to move at a straight line. Then we have another example here where we have a parachutist. So here the parachutist, if he was falling at a speed of 25 meters per second, so this parachutist, if he's falling at a speed of 25 meters per second, she will continue falling at the same speed in the same direction until there is an external force, of course. Why? This is because the weight, which is the weight of the parachutist and the parachute combined, and the air resistance are equal or have balanced. So this one is going to continue in the same speed and in the same direction. And now, when we have unbalanced forces, so let's see what happens when we have unbalanced or a resultant force that is not zero acting on an object. So the effect here is going to be in one of these ways. Or the object can speed up, the object could slow down, or the object could change direction. So if there is an external or an unbalanced or a resultant force on an object, if it was moving, it will speed up, or it will slow down, or it could change direction. Even if it was at rest, it could speed up or can't slow down, of course, but it can change the direction. So yeah, so that is when there is a resultant force. So here I have examples. So the thrust of an engine can change the car speed. So if the engine, if this speed, this car was traveling at a certain speed, and then now you add the thrust force by maybe pressing a little bit more on the pedal of acceleration of the accelerator. So what's going to happen, this can change the speed by increasing the speed. Or if you apply some brakes, in other words, now the resultant force is going to change. What is going to happen there? It is going to slow down. Or if you apply another force by turning the steering wheel, it could change the direction. So speeding up, slowing down, or changing direction is a result of another external force, or is a result of a resultant force. So I have more examples here. As you can see that the gravitational attraction of the sun can change the direction of a comet, or Another example, a squashing or a stretching a spring can change its shape. So we have said the resultant force is going to affect the motion, and now we are seeing in this case it is affecting the shape. Of course, it is also affecting the size in this case. All right, so here let's look at this example here. This question, forces balanced, forces yeah, or forces balance or resultant force. So balance forces, resultant force. So here I have a question. A car travels along a horizontal road at a constant speed. The image shows two of the three forces acting on the car. Calculate the size of direction of the calculate the size and direction of the dead force. So here we have the direction of motion. So this is the direction of motion, and we have two forces. So sorry, the first force is the by the engine, which is 2000 newtons, and then the second force is by air resistance, which is what it is 500 newtons. So we are expected to calculate the size and the direction of the dead force, obviously. So we have now another force that could be acting here for this engine. I mean, on this is the resultant force. So the resultant force is going to be 2000 newtons minus 5500 newtons, which gives us 1500 newtons now. So could I type here? So what we have 2000 newtons minus 500 newtons, and then we are going to get 1500 newtons, which is 1500 newtons to the left, to the left, because the greater force is towards the left hand side. So the answer is going to be this one. So this is the resultant force F. So this is the resultant force F, capital letter F. So it's yeah, that is that. All right, so let's move on to the next slide now. What's happening now? All right, so here we want to talk about the relationship between force, mass, and acceleration. The relationship between force, mass, and acceleration. So what we find here is that for a given mass m, the bigger the resultant force F, the bigger the acceleration A, and the smaller the force, the smaller the acceleration. So if we have a certain mass, or we have a certain object with a certain mass, suppose it has got 10 kg. So now if the force, the resultant force acting on it is going to be big, that is going to result in a bigger acceleration. But if the force acting on it is small, that is going to result in a smaller acceleration. In other words, the acceleration is directly proportional to the amount of force applied, or force is directly proportional to acceleration. But the better way to say it is that the acceleration is determined by the amount of force. The more the force, the more the acceleration. If you double the force, it is going to double the acceleration. For a given resultant force, now we have a force now, the bigger the mass, the smaller the acceleration A. So if you have a certain force, suppose you have a force of 100 newtons, the bigger the mass acting on that force, the bigger the mass of the object, there is going to be a smaller acceleration. So, and yet the smaller the mass, we are going to have the greater acceleration. So that is now a reverse. So this is an inverse proportion. So a force is inversely proportional to acceleration, or acceleration is inversely proportional to force. So if we have bigger force and then sorry, if we have bigger mass for a certain force, the acceleration is going to be small. And if we have a smaller mass, the acceleration is going to be big. All right. Yeah, so that is that. And then, so this one is not supposed to be here. So let me see if it's, I can, oh yeah, I can remove it. All right. So if a resultant force F acts on the body of mass m, the body will accelerate in the direction of the force. So if we have a mass m and we have a force, so the object is going to accelerate in the direction of this force, as we have said. So this gives us, or leads us to the equation: force is equals to mass times acceleration. Force is equals to mass times acceleration. So let's see how we can use these equations for calculations. All right, so F is the resultant force. F is the resultant force acting on the object, and it is measured in newtons. So we need to be very careful that the F is measured in newtons. And then we have M, which is the mass of the object, is measured in kilograms. So if you have been given grams, you have to convert that to kilograms before you can start calculating, because the SI unit of mass is kilograms. And then we have acceleration, which is the acceleration of the object, and it is measured in meters per second squared. Meters per second squared. So you can use this triangle to rearrange the force, I mean the equation. Force is equals to mass times acceleration. And then if we are looking for mass, so we say mass is going to be force over acceleration. And if we are looking for acceleration, acceleration is going to be force divided by mass. So let's apply this formula now. So here I have an example that I would like you to attempt to try to work it out. So a car accelerates at 2 meters per second squared. A car accelerates at 2 meters per second squared. So now we have this car that accelerates at 2 meters per second squared. So let me choose a different color here now. So so we have a car that accelerates at 2 meters per second square. The car with its passengers has a mass of 1500 kg. Calculate the resultant force. So we have A here, and then we have mass, so we want force. So now we want to calculate force that will be provided for this, that will provide, sorry, this acceleration. How much force that we need that can cause a mass of 1500 grams to accelerate at a speed of to accelerate at 2 meters per second squared. So please pause the video and work it and try to work out this problem. Thank you very much. I believe you have worked out the problem, and let's see if your answer is similar to mine. All right. So let's see if your answer is similar to mine. So here is my solution. So we know that acceleration here is, we have acceleration is 2 meters per second squared, as you saw it here. And then we have mass, which is 1500 grams. So this is mass. So I'm linking these two. So this mass is 1500 grams. sorry, it's 1500 kilo, yeah, 1500 kgs. Yes, so that is mass. All right, and then so we can use this equation. F is equals to ma. So we already know this equation. We saw it in the previous slide. So if we say F is equals to ma, what we will find is that m is 1500 kg times ga, which is 2 meters per second squared. So this is squared, so 2 meters per second squared. So what we're going to get here, we're going to get 3000, and then it's kg times 2 times meters per second squared. So we're going to get kg meters per second squared. So this is a combination of different units. So we are multiplying kgs and meters per second squared. So we get this one. So this one can be simplified by writing it as newtons. So now you can deduce from this unit that newton is a derived unit. It's derived from mass, it's derived from length, distance, and from time. So it's a combination of 3 different quantities. Then we are going to get our answer is going to be 3000 newtons. All right, and then now let's move on to our next slide now. All right, so let me remove everything here so that we are able to work out this next problem. So the next problem here, the resultant force of 2000 newtons acts on a mass of 1000 kg. Calculate the acceleration. So here a resultant force of 2000 newtons. So this is the force 2000 newtons. It acts on a mass of 1000 kg, and then we want to calculate the acceleration. So you can pause the video and work out on this problem. Thank you very much. I believe you have finished and you got the solution. So let's compare your solution with my solution now. So F, here we know that F is 2000 newtons and M is 1000 kilograms. So if we use this equation, F is equal to ma, we can rearrange it using the triangle shape, or you can just make it the subject of the formula here. We get that A is equals to F over M, which is 2000 newtons divided by 1000 kg, and we are going to get 2000 newtons per kg. So this simplified, because we're looking for acceleration, we will have our answer as 2 meters per second squared. So that is how it is going to accelerate yeah. So if we have a mass of 1000 newton, and now you apply a force of 2000 newtons, so the acceleration shall be 2 meters per second squared. So let's also look at this problem now. What do we find here in this problem? Yeah, this one. So here, calculate the mass. Let me change the calculate the mass of an object that has a resultant force of 300 newtons acting on it if its acceleration is 10 meters per second squared. Calculate the mass. We want to calculate the mass of an object that has a resultant force of 3000 newtons acting on it if its acceleration is 10 meters per second. So please work out this problem and pause the video and work out on this problem. Thank you. I hope you have done it. So here is the solution. We have F is equal to F ma, M is equal to F over A. So if 300 newtons divided by 10 meters per second, then we get 30 kg. So that's the mass of the object that is being accelerated at 10 meters per second squared by a resultant force of 300 newtons. So you need to be very careful that first you need to know what you have. Start from the question, try to highlight those quantities that you have been given. So here we've been given force and acceleration, and then now we want to calculate the mass. So then we can rearrange this equation. So I have an examination tip here. The resultant force is sometimes also known as the net force or the unbalanced force. So you should not confuse that. So if you see a resultant force, or you see a net force, or you see unbalanced force, so you must know that that is one and the same thing. Avoid referring to air resistance as wind resistance or air pressure. These are incorrect terms and will lose your marks if you use them when you are actually meant to use air resistance. So if you want to use air resistance, do not make the error of using, or the mistake of using wind resistance or air pressure. So those are different concepts. So just write air resistance, or we call it a drag force. All right. Thank you very much. So this is the end of our presentation today. So make sure that you also watch the next video, which talks about friction. Thank you.